continue with these case studies, and the theme here is needs assessment and then design of our applied research and education program in response to those needs, the trends, the issues, the common themes that we see in California when it comes to pest management. So you heard already about alternatives to glyphosate. You know, it's an emerging need in response to public sentiment, and a lot of you guys work for municipalities where you may be asking those questions. Well, what do we spray now, right? So I'm going to present two other case studies, and I'm an entomologist, and I'm not willing to work on the weeds. So I'm going to be talking about creepy crawlies with multiple legs. Um, and, you know, these are kind of new pest systems or under researched pest systems. And that's why I decided to focus on them when I did. So the first one here is really interesting. Um, Turkestan cockroaches. These are large, scary cockroaches, you know, not the little cute ones that you see in the kitchen. And these guys live and breed outdoors. But what happens is they come inside during their nightly foraging, and this can lead to a lot of unnecessary pesticide application. And we were seeing this especially at schools in California, public schools. So maybe you can see which one's the laser, the bottom one? The bottom. Yeah, so in this image here, you can see this is an exterior door of a classroom at a public school. And so these cockroaches are free to enter during their nightly foraging. And of course, in the morning, the teacher or the students may see that cockroach. That may drive a lot of pesticide application indoors, even though these cockroaches are actually living and breeding outdoors. So it's a system that kind of gained prominence in the past 10 years or so, especially in Central and Northern California. I think Southern California, they've been dealing with this pest for a little longer. But basically, we had pest control operators using perimeter sprays around buildings. And one of the issues there is the pyrethroid insecticide regulations that Carrie touched on. So some of those applications became unavailable. But the bigger issue is they simply weren't effective. If you have a giant gap under the exterior door, even if you have an effective insecticide there, the cockroach is still going to enter the building. It will die if the material was well applied. But the problem is the cockroach is getting in. So there was a need expressed by the industry, also by the state. What can we do about this? Are there other ways to deal with this problem? And so what I wanted to do is forget about the sprays and see if we can manage these cockroaches with baits only, all right, to really reduce exposure and hopefully increase efficacy of the program. First, a little bit about Turkestan cockroaches. The genus on these guys has changed a lot over the past couple of years. We used to call them Blatta lateralis. Blatta is the same genus as the Oriental cockroach, which you may be familiar with. Currently, we're using the genus Periplaneta, which is the same genus as the American cockroach. So that may change, but essentially, we're talking about a large species native to an arid region of the world. So native to Western Asia, where we have desert climate, Mediterranean climate. And so it's very well adapted to California and the American Southwest. We think that the cockroach got to the United States by hitchhiking on military equipment that was brought back from Western Asia. But you can also purchase these guys online to feed lizards. Uh, they call them red runners in the herpetological circle. I guess because the nymphs are reddish, they can't climb the glass terraria. So they're very popular with lizard enthusiasts. And you can buy them online. You get live insects delivered to your door. So maybe one or both of these mechanisms has introduced the species to a new region where they do very well, and they actually have outcompeted Oriental cockroaches in much of the American Southwest, and they're now considered the most common peri-domestic cockroach species. And so what we saw at some of our public school sites was very large populations, biblical populations, the type of populations where when you're walking around, you might crunch some of them, as if you're doing a night inspection. There was a public high school in Mendocino County where they were having issues because it was football season and people were watching football games at night. The cockroaches were crawling on them, crawling into their backpacks and crawling on things. Not to mention just, all over the campus, every nook and cranny of the campus. And so there was actually a Facebook group called Eradicate the Cockroaches from Ukiah High School, and at its height, it included more than a third of the residents of this small town. Ukiah only has 16,000 people, and there were like 6,000 of them on this Facebook group. There were people making illegal applications at night. Moms were applying white powders of unknown origin, and so there was a major need. The state contacted UC, the Department of Pesticide Regulation, sponsored some work to intervene. And so I came up with this bait only idea. I'll mention that these cockroaches cause similar issues all over the state. Um, this was in Fresno County. This was a warehouse, uh, food distribution warehouse, where they had cockroaches on the roof. And so they realized that they were vertical cracks in the facade of the building that the cockroaches were using to harbor and then also travel all the way up to the roof. Once they were at the roof, they were able to get in through unscreened skylights and vents. And so they were, in the building. So it's a major issue all over the state. And insecticide sprays will not solve this problem. So what did we do? We found some gel bait materials that were labeled for outdoor use, and we did something interesting and unique. We applied these things in bait stations. All right. In some cases, we used these triangular rodent bait stations because they were lock and key. We could use those at a school site and be in compliance with the Healthy Schools Act. We also came up with this cool method where we could apply bait to subterranean utility ports. So we would fill PVC slip couplings with the gel, drop them into our utility ports, and they were inaccessible. They were right there where the cockroaches were harboring. These are the kinds of environments where these Turkestan cockroaches would harbor and breed. The school sites also did a lot of exclusion for us. They installed door sweeps, but they also filled a lot of these gaps in their hardscape where expansion joints had rotted out, the sealants had gone missing, and so they were able to eliminate these hiding places for these cockroaches. These are some special trash cans they installed with pedestals, which raised them up off the ground and eliminated that hiding place as well. And what we saw was that using bait alone, we could reduce these populations dramatically within only 1 month. So this is our site, which had very high biblical populations. And after just one bait application, these arrows represent the bait applications, we were able to drop, and this is in the middle of the summer when cockroaches are really going gangbusters. Um, and we were able to maintain that level even today. The level is low. You can still find cockroaches at this site, but they're not creating the problem that they once were. So this is a bait only approach. Um, this is the kind of activity we were seeing every night. So this is a glue trap that we would place outside the building, so next to an exterior door, just for one night. You can't leave glue traps outside. You're going to catch lizards and non-target organisms. but we would put these glue traps out at about 9 p.m. and then come back at 5 or 6 a.m. to pull them before the students came to the site. And this is how many cockroaches could have entered that exterior door, every single night. So that's the density that we had. We were able to drop it. The reason we were so successful is because cockroaches are cannibalistic. So once you kill one of these animals, its buddies cannibalize its corpse, sometimes before it even dies. So this is a male Turkestan cockroach on a sticky card, but see, he's at the edge of the glue. So his buddies were able to sit there and eat him, probably alive. They ate everything except for the sclerotized parts with not much meat. So this behavior helps us to amplify that insecticide application and get secondary and even tertiary mortality. We were able to replicate this at other school sites. This is a site with much lower density where we were able to play around with timing of application based on life cycle. So this cockroach only has one generation per year. There's a little bit of overlap, but what we found is that if you bait in at the end of the season, so this is October, the population rebounds, and that's because the eggs have already been deposited. So you might kill some adults that are running around, but the eggs they have deposited will hatch and be ready, available for next year's population. On the contrary, if we were to bait during the period when mating and egg laying was occurring, we could get sustained population reduction in the following year. We published these results in the Green Bulletin, which was mentioned by Carrie, as well as in Pest World magazine. That's a National Pest Management Association magazine. And what we have seen is that the industry is starting to respond. So we have seen in the pest control industry increases in baiting services provided and decreases in spray programs being provided for this kind of peri-domestic species. And that's because the spray programs don't work very well. They don't solve the problem. They additionally create problems for environmental contamination and pesticide exposure. So we have received some testimonials. I've talked to some national companies that are shifting their protocols away from sprays to bait only for these kinds of large paradomestic species. So this is a complete story where we have taken a need that has emerged, designed some research, extended the results to the industry, and the industry has responded with changes in behavior. So I'm very proud of this story. Another case study, which is not as far along, but I hope to have similar success with, is working with biting mites. So these are blood-feeding parasites that feed on vertebrate pests, rats, and birds. And we think that they are very, very common in these pest systems. The problem is we don't have good tools to confirm that we have biting mites present. The other issue is that when we remove these vertebrate predators or vertebrate pests, I should say, like the rats and the birds, the mites can continue to survive and wander around within a structure, biting people. And some people will exhibit really significant dermatitis in response to this. So there's not much known about these guys, and there's a lot of misinformation about these guys. Online, you can find all kinds of horror stories. You can find all kinds of misguided factoids and misinformation. So there's not a lot of research-based guidelines on what to do about this problem. So we designed a research project where first we want to ask how common are these mites within California's homes and structures? And can we start by developing some kind of identification guide? And this is important because there's lots of mites out there. just because you see a mite crawling around doesn't mean it's one of these blood-feeding biting species. So we wanted to create something that pest control operators could use, or maybe vector control agencies, to identify the mite species using tools they already had. So again, more on the pest system here. Um, we're mostly talking about mesostigmatid mites. So they're mostly free living. They don't live on the animal. They can be considered nest parasites, where they spend most of their time hanging out in crevices or in the nest of the vertebrate host. But when the vertebrate host is resting, they go to that animal to get their blood meal. Um, there are two parts of the life cycle which must feed on blood in order to continue the development. And the problem, of course, is that when we do kill or remove things like this Norway rat, those mites can wander sometimes hundreds of meters looking for something else to sustain them. And they cannot survive for very long, and they cannot reproduce without their primary host. So without that rat, without the bird, they can't keep the life cycle going. But they can persist long enough to cause a problem for the humans in that building. And research shows that it may be up to 60 days where you could have wandering mites. And the reason is because uh, the protonymph um, feeds on blood, but then the next stage, the deutonymph, doesn't feed at all. All right, so there's a resting stage, and so let's say you eliminate all of the rats when your mites are protonymphs, they still will metamorphose into adults and be hungry for blood at that point. So based on temperature, there may be up to 60 days when this problem persists. Um, in order to manage these mites, you have to manage their primary hosts. That is the strategy. Remove the rats, remove the birds, clean up the nesting material. But that's easier said than done. And the other issue is once you remove all that stuff, you may actually increase the dispersal of those mites away from the area where they used to be able to find blood. We don't have any targeted detection tools. There's no monitor or monitoring device designed to catch these mites. Pest control operators usually use glue traps that they're deploying for other crawling pests, cockroaches and spiders and silverfish and whatnot. And every now and then they'll catch a mite. Um, but we need something better. The other issue is when you do catch a mite, identification is tricky. These guys are not invisible. They're about half a millimeter to 1 millimeter, so about the size of the period in a printed paperback novel. Um, but you can't just look at them and identify the species. Sometimes you can't even look at them and say that's a mite. It's a speck with legs. So usually you have to lift a specimen off of a glue trap, put it onto a microscope slide, and then look at it under a compound microscope in order to identify it. Once you do identify that you've got mites or bird mites, there's no control measures that have been proven effective. So we don't have any tools. The tools are all directed at the primary vertebrate pest, that's the host. We think that this issue is very widespread. Think about how many roof rat infestations we have in California. All those roof rat infestations likely harbor these mites. All right. Think about birds that nest on structures or in structures. They likely have biting mites associated with those nests as well. What about backyard chickens? This is a photo I took when I was doing field work in San Jose. It's a chicken coop that somebody installed right next to their home. And there's an exterior window behind this that leads to a bedroom, you know. So you will find mice on domestic fowl, and they will move to humans if given the chance. And I think that, we have a lot of cases of what we call unexplained dermatitis. My wife presents all the time saying, "What bit me? Why do I have this rash on my arms?" And there's no explanation. No dermatologist or entomologist can look at your skin reaction and say, "Well, a flea bit you or a bed bug bit you." Um, but sometimes we see this unexplained dermatitis and we think people are delusional. There's actually this delusory infestation condition, which is a psychiatric condition. But how many of these unexplained dermatitis cases are actually caused by these mites walking around that are hard to see, hard to detect, hard to identify? So far, this project's been going a year and a half or so. We've made about 40 collections, and almost all of the biting specimens we've collected are what we call the tropical rat mite. These are associated with, are you waving at me, Crystal? No. Oh, sorry. These are associated with roof rats, Norway rats, squirrels, sometimes domestic rodents. But 80% of the biting cases have been attributed to this species. We've also found fowl mites, which can be present in domestic fowl, like chickens, but also on migratory birds, that nest in and on structures. And we've had some interesting outgroups. People say chiggers. You guys don't have chiggers in California. They're actually quite common in certain parts of the state, and they will bite and cause dermatitis. But they live outside, so they're considered kind of an outgroup for this project. Likewise, there's a group of mites called concrete mites, which are red, they're fast moving. You see them in the spring, they're feeding on pollen, but they crawl all over patio furniture and sidewalks. And let's say you're laying by the pool, they're going to be crawling on you, and they will bite defensively, and they will cause dermatitis. So, what about monitoring? We have seen some behaviors which have been interesting for monitoring. Um, Negative phototaxis, so these guys are moving away from light. Thigmotaxis, which means they find crevices to hide in. They like to be in tight crevices. This is the most interesting one to me, negative geotaxis. That means they crawl up, all right? So if you're putting glue boards on the ground, you're not going to catch very many. We have found that if you put glue boards vertically on walls, or sometimes even horizontally on ceilings, you're likely to catch these mites. And it's because of a hunting behavior, which was documented by pest control colleagues in Pest Control Technology magazine. They observed it seems the mites travel up walls and across ceilings where they drop on sleeping victims below. So a lot of times we talk to people who have these biting mites, and they say, I didn't see them until one night I was on my phone and it dropped onto the screen of my phone. I saw this little animal crawling around. Um, and we think this is a common host finding behavior for this group of parasites. So what we have done is develop some trapping techniques. This is just showing that you'll find mites in the middle of the glue trap. Does anyone here monitor with glue boards? A couple of us. So you ever see something in the middle of the glue board? You wonder, how did it get there? In this case, it's because it fell down. If you set one of these traps on a wall, you're going to catch the mites on the edge of the glue because they're crawling up or down. But if you set them on the floor, like the pest control operators typically do, it's you're going to catch these mites in the middle sometimes. And you may wonder, how did this happen? Some people say, oh, it's static electricity. But we've actually observed this behavior where they will fall from a vertical surface. So one thing that we've done is we've been using carbon dioxide in our experimental monitors to make them more attractive. We use a simple sugar yeast reaction, and this releases a small volume of CO2 over about 10 or 12 hours. And we also have played around with heat, just hand warmers that you might use when you're skiing. You can break those, they emit some heat also for about 10 or 12 hours. And so what we've seen is that so far these attractants do seem to produce better catch rates than glue boards by themselves. But what I'm telling pest control operators is if you suspect biting mites, try putting your glue boards on the walls. You have to do this places where people are not going to tamper or get stuck. But you'll catch a lot more of these guys on walls than you will on floors. We're hoping that in the future we can develop some kind of a really fine-tuned monitoring tool that utilizes carbon dioxide. Carbon dioxide is emitted by vertebrate animals through respiration, and it's a really important host-finding cue for these blood-feeding arthropods. So when it comes to the identification, our original hope was that we could use macro photography to identify these mites instead of the traditional compound microscopy. The problem here is we were totally wrong. The macro photography takes some beautiful images, but it does not show you the characters that you need to see in order to identify mites to species or even to the family. So we are currently developing photos both from macro as well as micro photography. And the goal is to create a guide that will include all of our common species with the morphological characters that you'll need to identify the species and to produce this as an online interactive key that's based on photos that we've taken. So the idea is that we will train pest control operators, vector control agencies to do their own mite identifications, considering that there's a small number of species that you will find indoors that bite people, and using a dichotomous key to identify that species. The reason this is important is if you identify something as a bird mite, well, then you're looking for where the birds are, right? Then you can eliminate the birds nesting and roosting in or on that building. On the other hand, if it is a rodent mite, then you may be looking instead for the roof rat nests and access points. So your pest management strategy is going to depend on the pest identification, as usual, right? So it is more complex than we thought. We're not going to be able to produce these macro guides. We're going to have to go micro. But still, the point is, we're responding to a need, kind of an under researched system, and trying to create some tools that the industry can utilize. So far, professionals that have learned about this project are realizing that these mites are everywhere. Anytime you have rats or birds, you're going to have these mites. We can catch them with our existing tools. We don't have to produce some new tool, but we have to use our existing tools differently. So the vertical placements have been very effective when we suspect these biting mites. In the future, I do hope for some active, carbon dioxide lures and monitors. And so currently we are also teaching professionals how to slide mount and identify mites, teaching them how to fish so that they can identify these guys in the future. And then look for this interactive guide to be published on the UC IPM website, hopefully this year, later this year. So those were 3 case studies. Oh, you cut off my image, that's okay. So those were 3 case studies that were showing you how we use the needs assessment process to design applied research, produce tools, and hopefully change behavior and increase knowledge in our client base, which includes pest management professionals. If you'd like to learn more about what we do at UCIPM, check out the website. There's all kinds of tools, keys, guidelines in there, pesticide information. You can sign up for the green bulletin. So if you don't have this website bookmarked, do it now. And that's what we've got for you. Thank you so much.